Now we're at a point in our knowledge of gases and their behavior and the mathematical equations that dictate their behavior. Now we're at a point where we can talk about using stoichiometry and chemical reactions or chemical equations to do calculations. So to do stoichiometry, which just means mole-to-mole ratio of reactants and products, when doing stoichiometry involving gases, you're still going to have moles as being the gatekeeper, meaning you're still going to have to figure out or find out how many moles of a gas you have. But you now have another tool in your toolkit to find moles of a gas, which is good old ideal gas law, PV equals nRT. So in these problems in this chapter, when dealing with gases, you're going to use PV equals nRT along with stoichiometry and a balanced chemical equation to figure out amount of moles of a gas. And then you can use those coefficients in the balanced equation to convert to other quantities that you may be asked about in the problem. So, for example, let's say I have this balanced chemical equation, and I want to know how many moles of NH3, so how many moles of product, are formed by the reaction of this volume of hydrogen, so my reactant. I want to know from this volume at this temperature and this pressure, from my reactant hydrogen, how many moles of NH3 do I have? Now, if I just asked for moles of H2, that would be easy enough. You could just use PV equals nRT. But I want to know how many moles of NH3. So in this problem, we need to do two things. We need to first use the ideal gas law to solve for moles of hydrogen first, and then use the coefficients of the balanced equation to convert to moles of NH3. So here's that same problem. We have a volume, a pressure, and a temperature, and thankfully I gave you the volume in liters, the pressure and temperature, or the pressure in atmospheres and the temperature in Kelvin. We know our gas constant. We need to first figure out how many moles of hydrogen gas we have. Because why hydrogen? Because we have information about its volume, pressure, and temperature. We don't have that for NH3. So use the ideal gas law to solve for N, then plugging in the appropriate values that were given, and then seeing our units cancel appropriately. We're left with moles, and so specifically moles of H2. So we now know how many moles of hydrogen gas were reacted. Now we can go ahead and use coefficients of the balanced equation, specifically the fact that for every 3 moles of H2, there are 2 moles of NH3. And so that statement can be written in the form of a conversion factor, which I did down here. And so writing it like that, you can see your moles of H2 cancel. I'm left with moles of NH3. So doing that multiplication and division should give you your final answer of 0.073 moles of NH3. So in these problems, when you do stoichiometry with gases, you're still going to use coefficients of the balanced chemical equation. The only new part is you now have a new way to figure out how many moles of a species you have by using the ideal gas law. We will use the ideal gas law and stoichiometry again in the next problem where we look at collection of a gas over water.